Dear colleagues and friends, let me on behalf of the Russian Geological Society to congratulate you all on the start of ISADET 22 conference and to wish fruitful work and useful discussions. Let me introduce myself briefly and my co-authors. I'm academic secretary of the Russian Geological Society since 2009. I was head of medical geology division since 2005 until 2019, when Dr. Farkhudinov was elected as a chair of this subdivision of Russian Geological Society. In my presentation, I would like to highlight some important aspects from my point of view in activities of International Medical Geology Association and its significance for promotion ideas of this actual branch of knowledge, environmental sciences in Russia and in newly independent states and all over. As well as you could see on the first slide, the intensive work on creation of IMGE started in 1996 after International Union of Geological Sciences approved creation of International Working Group on Medical Geology, IWGMG. This subdivision adopted medical geology as a term and as a branch of knowledge in 1997. And in 2000, UNESCO approved the new project IGCP 454 Medical Geology in recognition of the importance of geological factors in human health. Such important dates like March 2002, International Union of Geological Sciences gave special project status to the group, and Olle Selinus, Swedish scientist, geochemist, became a director of this special project. Bob Finkelman became co-director, geology. Jose Centeno became co-director, medical sciences. In August 2004, 32nd session of International Geological Congress held in Italy, Florence, approved creation of the International Medical Geological Association, IMGA. Attended 150 participants from 71 countries. IMGA formally launched January 24, 2006. And first of all was created as educational committee. From left to right, you can see a photo with establishers of Medical Geology Association. In your left, Robert Finkelman, geochemist from the United States, who played the leading role in the creation of the separate branch of environmental sciences, together with Jose Centeno, who is a toxicologist from Ministry of Defense of the United States, and Peter Derbyshire, an expert in chemical peculiarities, characteristics of dust, and Olle Selinus, who was first director of group and Medical Geology Association. His role in Medical Geology Association was very significant because he was one of those who identified for the first time the reason why the moose disease happened in Scandinavia in 1980s. What is medical geology? The recognition is an emerging discipline in environmental health, but it has a very deep historical roots. And Hippocrates in 5th century BC said once, if you want to learn about the health of a population, look at the air they breathe, the water they drink, and the places where they live. Medical geology, the science deals with the geologic factors that have a bearing on human, animal, and plant health. Is the scientific discipline that examines the impacts that geologic materials and processes have on human and ecosystem health. Medical geology deals with the cause of the disease, but not its cure. During the 1930s and subsequent period in Russian Federation, it was the same time animal and plant scientists made much progress in studying health impact caused by excess or deficiency of trace elements in animals and plants. Geochemical data triggered interest of geologists and healthcare professionals to study possible relation between the geochemical nature of an area and incidence of disease. On this photo, you again see the Dr. Robert Barry Finkelman. The creation of subdivision in medical geology of the Russian Geological Society is closely connected with this scientist from the United States. 20 years ago, medical geology arrived in Russia and the newly independent states. Robert Finkelman lectured on May 2, on the 2nd of May of 2002 at the State Geological Museum, Vernadsky Museum in Moscow, at his introductory lecture. And I'd like to say that my author is Dr. Farkhudinov, is now the deputy director of this museum, and he is a great expert in medical geology and also participates in attendance here. Dr. Robert Finkelman is famous because he, for the first time, recognized the reason why the people suffered from geological factors in Guangxi province in the in China. He, together with Zhang Baoshan, Chinese scientist, Chinese geochemist, revealed that the population of some villages of China in Guangxi province use the coal in their household for as a fuel, firstly, and suffer from different diseases which had not been recognized, which hasn't been recognized then. And they highlighted this situation and started studying the geological factors of this problem. And you see Bob, who is does his field works here, and he explored then the geochemistry of coal all over the world, and was involved in the problem of coal ecology as well. And he demonstrated that people who used the coal in household took for this aim very polluted coal with arsenic, because it was the only fuel for households there, and they had to use this coal in the household. But further research showed different aspects of the effect of geological factors on human health. This is famous slide which we often use for demonstration of the achievements of medical geology, for instance. It was published for the first time in 2008 in episodes by Dr. Finkelman and his colleagues. And you can see the characteristics and different pictures, how different diseases look like. And on your left, you see the number of diseases which is connected with fluorine, for instance, which also could contain in coal. And another picture is black lung. This is disease of occupational disease, and the reason is the sulfides, which is soluted in by the human liquids, and they fill the alveoles, and a man or other human die due to asphyxiation, for instance, or other other diseases, lung diseases. Selenium deficiency, the problem of endocrine system due to deficiency of selenium in different natural environments, soil, water, and etc. And people the population do not consume it with food chains and suffer from this disease, selenium deficiency, cordial diseases, and other which is connected with endocrine system. And you're left to see selenium joint disease. This is a disease which was identified in Africa and southeast of Africa, where the soils, which is poor with useful components, with nutrients, and people suffer from. And by the way, mostly female population suffer because they are they have to stay at home, but men's population suffer lesser from this disease because men used to travel and try to look for money for the families. And many other diseases which are on are demonstrated here. And see Balkan endemic nephropathy, which is connected with polycyclic aromatic hydrocarbons in water in Serbia. This is endemic disease, which is caused with water which is polluted with different organic compounds. And again, arsenic in water, which is a reason which causes the black foot disease and diabetes. The initial stage of the organizational activity was finalized with this edition, Essentials of Medical Geology. You see here on the front list, you see the Oli Salinas, Brian Alloway, Joseph Santana and others who was the first first scientists, group of scientists who discovered and opened medical geology for scientists all over the world. And this edition is intended for geologists, geochemists, soil scientists, and many others whom you could see on the slide. Russian Federation joined to Medical Geology Association in 2006. But the Medical Geology Division was founded in the structure of RosGeo in 2005. And you see the first group of countries which composed the structure then. Our structure was had a special recognition award for a most significant impact on the development of medical geology in the region. We got it, we were awarded in September 2011. We not only joined to the organizational activities, and Russian scientists participated at many projects, like you see on this slide, and Man Geosphere, which was edited in Earth Science in the 21st Century series, and Medical Geology, the second book of Medical Geology Association, which was issued in 2010. Medical Geology Status and Prospects, the edition of Russian Geological Society, also in 2010. Our colleague Georgi Rudko was the editor of this edition, Вступ до медичной геологии, the introduction to medical geology. And the top of our activities coincide with organization MedGeo70 in Moscow. You see dates here, where 187 participants from 30 countries attended to this conference. And I'd like to say that favorable to this event, we learned that medical geology studies embrace different aspects of medical geology in Russia and in the United States. For instance, urban and mining medical geology, environmental geochemistry, medical radioecology, interactions, heritage of academician Vernadsky, participation of representatives from the independent states at 33 International Geological Congress session in Oslo, Brisbane, NetGeo. You see 4 conference which used to hold one time in 2 years. And as well as many other conferences where we shared with colleagues our achievements. And we participated in a conference in Turkey, Belarus, Armenia, Bulgaria, Ukraine, and Russia. But I would like to highlight 2 paragraphs here among our branches of medical geology we work on. Geochemical mapping territories with the use of GIS in terms of both epidemiological and biological states and modeling their spatio-temporal dynamics under distinct environmental scenarios. And another one is, one more is baseline environmental, medical, and social assessment of the territories of geological risk, and abbreviations BEMSA. Why it is so important? We would like to share our opinion about the significance of baseline environmental, medical, and social assessment, and opportunity to apply it in Russia, for instance. And we would like to demonstrate how to bring to decision makers a significance of medical geology research through the BEMSA. And as well, medical, environmental, and social questionnaire surveys in the territories of geological risk of Russia as the methods to demonstrate decision makers the significance of medical geology research simultaneously with social surveys. Baseline environmental, medical, and social assessment, main purpose of it is to take into account environmental aspects in the design and implementation of strategic documents on the basis of the principles of sustainable development. The importance of this strategy is explained by the need of incorporating environmental aspects in planning for more effective management decisions. In international practice, BMSA is considered as an efficient instrument to achieve sustainable development. For myself, this approach, this methodology started with learning this article, which was published in 2008 by Andrei Amaral and his colleagues, and titled as Essential and Non-Essential Trace Metals in Scalp Hair of Men Chronically Exposed to Volcanogenic Metals in the Azores, Portugal. Why it was very important for me. On average, men exposed to volcanic emissions in the Azores presented high concentrations of cadmium, copper, lead, rubidium, and zinc, but not selenium. By using high resolution and inductively coupled plasma mass spectrometry, it was done these investigations. The obtained result demonstrated that humans living chronically exposed to volcanic emissions show high concentrations of essential and non-essential trace metals such as zinc, lead, cadmium, and copper in scalp hair, and thus suggest that this type of exposure may be as harmful as living close to industrial facilities. That's why we can consider the territories of geological risk not only the natural objects, but for instance, objects of industrial type, metallurgy plants, mining operation plants, and etc. And on this table, we see the comparative results of comparative study of concentrations of different elements in scalp hair caused by volcano activities and mining industrial activities, which we can see that they are quite similar. How it used to takes place, I mean, the penetration of the different harmful elements, which could be considered as a technological as well as natural. For instance, as we like to demonstrate it on the pattern of arsenic in Chile. The research was done by paleopathologist Marvin Allison, and he shared with me complimentary copy of this photo with a mummy of the inks of the Indians of Inks period, and the tissues, arsenic in human tissues, was in very high concentrations. It was identified in the issue of the ancient patient. You see the arsenic in hair, arsenic in skin, arsenic in lungs. It was identified everywhere. But what was the interesting fact? Marvin Allison and his colleague identified the clinical manifestation of chronic arsenic poisoning among 180 respondents in Antofagasta, Chile in 1979. People consumed the same water as ancient patients, and they got sick, and we could see the diseases they suffered from: skin pigmentation, hyperkeratosis, chronic rhinitis, chronic cough, bronchopneumonia, Raynaud's disease, cyanosis, chronic diarrhea, abdominal pain, and many others. And we see that the ancient patients and modern patients suffer from the same diseases caused by very high concentration of arsenic in natural environment. But how to bring to this makers and significance of medical geology research? We made up our mind to demonstrate the achievements of medical geology to officials of Kamchatka Peninsula. Why we did it, and we are going to continue this process. We composed a proposal which is dedicated to the staging of interdisciplinary research in geology and health on the territory of the Kamchatka Peninsula, which contains volcanic and seismic activity. The proposal was approved and recommended for practical implementation by IMG Executive Committee. We compared geological situation in Chile and in Kamchatka. I'd like to say that many foreign experts recognize Kamchatka as a dangerous territory in arsenic pollution. They were absolutely right, because the soils in Kamchatka are really polluted with arsenic, natural component of the environment, but no information about the problems which could be in connection with arsenic in natural environment here. But we know exactly what happened in Chile in the 15th century, in the modern times, only 50 years ago. That's why geological analysis helped us to make a conclusion about necessity to organize the works, the research works in medical geology there in a volcano area of Kamchatka region. You see here the map, the scheme of displacement of many volcanoes which are in actual work. And the initial stage of unsystematic research on geology, ecology, and health in this region was finalized in 2005. Negative tendencies in the health status of population were revealed on the basis of questionnaire surveys conducted among 154 residents of Ust-Kamchatsk, a small coastal settlement facing the Pacific Ocean. We can see on this scheme the location of Ust-Kamchatsk and two volcano and actual activity And the results of that questionnaire survey, which was done in 2004-2005 by scientists from St. Petersburg, demonstrated that there are very few people who can who possess good health, healthy 1/4 of the total amount of population. Children around 40%, needing outpatient examination around 40%, and 1/3 among children population and teenagers. Needing inpatient examination 1/5, and almost the same for teenagers and kids. Needing hospital 16.2% among adults and every 10 kid in this area, which is exposed to the volcano activities. And another table demonstrates the results of medical questionnaire survey population and status of health of the population self-evaluation. Healthy, almost the same we saw on the previous table. Chronic diseases assumed after arrival to the Kamchatka region. The data speaks for itself. Cardiovascular diseases, ocular, and others which were assumed after arrival to the Kamchatka region. And deterioration of health condition because of living in the Kamchatka region, you see more than 1/2 of population responded with cardiac pain, dyspnea, headache, insomnia. We tried to combine this data with geological, for instance, geological objects, and what we see further, that mortality is very high there in this settlement. Birth rate, you see, very low. New onset, no, but this is data of 2009 in accordance with the state report. And but the reason they postulated, but they did not demonstrate and show the reasons. But we would better see the reasons why it happened, and why more than 60% of population would like to move to other place. But what we can see together with you on this slide, this is not a snowstorm. No, this is not a snowfall. This is a ashfall. Ashfall, which happened, for instance, in March of 2015 from Shiveluch volcano. So the main target of the proposal is to start systematic medical geology and social studies in the Kamchatka region on the basis of new data obtained by medical geologists from IMGA and IMGA chapter Russia and newly independent states. Novelty of the planning research approach is concluded in realization from the social and medical geology questionnaire survey conducted among the population of the Kamchatka region. The cohorts are the populations live in small settlements and the city of Petropavlovsk-Kamchatka, where they are under the influence of volcanic products and environmental as well as climatic factors which are negatively and affect human health. We highlighted the problem by publishing special articles in the local newspaper. The scientists of the Institute of Seismology helped us to do it, and during the work preparation of the project, we published a very interesting book, which is titled "The Civilization Through the Eyes of Catastrophes, Natural and Social," where the special chapter is devoted to the problem of medical geology in Chile and in Kamchatka region. We compared to regions of the world and had a special conclusion. And in conclusion, I would like to say that cross-disciplinary use of geological and medical data from locations where populations are exposed to volcanic eruptions, products of seismic activity in industrial enterprises. Such an approach offers an opportunity not only to advance scientific understanding, but ultimately to help the decision makers in their activities in protection of public health. It seems to me that we have a common task targets together with scientists from all over the world, because the approaches which can provide the methodology of baseline medical and geological system of knowledge poised for organization of preventive measures in environmental protection, as well as in medical care in the territories, economic growth, and just living of the population is very important. That's why my opinion is we need to go further and to join our efforts and use any opportunity to demonstrate the privileges of our branch of science. I thank you very much for your kind attention.